Hey, welcome back to the PRF tutorial series. So in this video tutorial, we'll look at the main file, which is, for this example, we'll look at the analysis for July 25th, 2012, experiment number 1. And we'll look at the high-level functionality of each MATLAB cell block. So every time you do 2% sign, that is the beginning of a cell block. And here, so when you put a double percent sign here, that's going to be the end of the cell block in the beginning of another one. So at the start, I usually start with clear, which is basically mean clear all memory. Close all, I mean close all the figures, the windows for figures. And CLC is just clearing the command prompt. Alright, so here the first cell block is basically the variable definitions, the global variable. So we define the year of the experiment, the month, the file number, and these are all notes taken from the MRI personal notebook that I have with me, which you may need later on for notes on the experiment. So the threshold here is, well, I guess I'm kind of going over in depth for this cell block because it's kind of simple, but I'm not going to do that for all the cell blocks just yet. Yeah, for these one, I'm just going to go over like the basic functionality of that before we go in depth up what like the code behind the function. So just keep that in mind. But this first one is pretty much straightforward. The threshold here, the variable threshold is basically the threshold we can use for masking later. So you know, for the MRI cross section, you have air as the background, right? So you have the tissue as your target, whatever, and then you have your air as the background. And basically, you want to mask that air from your calculation, so you need to set a threshold for signal threshold. So this is gonna help us later to mask out the air background. And D1 is the first dimension of the MRI image. It's 128 pixel. D2 is the second dimension, is 128 also. So it's 128 by 128 image. And the number of slices is 6. So there are 6 cross sections in this scan. And cycles tells you the number of repetition in like as a function of time. So this is like in a time, the time dimension. So it's like first dimension, second dimension, third dimension, and then this is equivalent to time. So every cycle means there is a step in time, and that step is something that you set up with the MRI, and yeah, that can be you can find that information for the time step in the MRI method file, which I'll go in detail later on. But that's usually something that you tell the MRI operator, and then they'll tell you like the exact time for per repetition or per cycle. Yeah, and that's something I usually write down the notes here too in my MRI handbook note. Alright, so I was looking at my notebook. So here is where you select the nth slice that you want to analyze. So here you define how many slices are there in this file, and here you define which slice you want to analyze. So I want to analyze the middle one, the third one. TE is the echo time, and that's one of the crucial parameters for this temperature estimation. Channel here is where you define the channel number that you want to use for the optical sensor. So sometimes you have up to 3 channels, and you want to just pick one that's closest to where you want to analyze. I mean, you can add more channels if you want, but this is the starting point. I just pick channel 2 in this file. So this file has like 2 channels in there, and I pick the second channel. Alright, so the first thing that happens here is basically when this is where you open up the file and you load into memory, yeah, basically. And obviously the magnitude file is it's called M file. This is the real part. It's called real file. This is the imaginary file. So these are the outputs, and this is the function that I defined. And the inputs for this function is year, month, file. These are strings that we defined earlier. Alright, so this is part is just for loading the raw data into memory, and the output will be these 3 files. The next thing we need to do is use a masking technique, basically based on the threshold we defined earlier, and mask out the background. So once we have the mask file, we're just gonna output to a variable that has masking on it. So this is the mask MRI data. The next cell is partition. So this is when you manipulate these one-dimensional binary data into 4 dimensions, if you will. So just imagine a large string, and then you kind of like fold it so that you have 4 dimensions. I'm not sure if that's a good analogy for that, but basically it's a series of a number, like very long line of numbers, and you want to fold it into an image, because each number represents a value in the image. And the original raw data is not an image file, it's just a long string of numbers, and you want to partition it, fold it in such a way that it can be plotted as an image. So I just fold it into these dimensions using MRI, the mask data, as an input. And we're going to go in more detail for this function, so just keep that in mind. So this is the folding part, okay? Select slice of interest. So this, you know how we had started off with like 6 slices? This one, we just select one, because like we don't want to be carrying around a lot of data, and that takes a lot of RAM, and we just want to select the one that we want to analyze at this moment. So we just select the end slice of the data. So that's going to produce these outputs here, and it makes more sense once you open up the MATLAB M file for this slice select. So the next part, so we select the slice of interest. Now we need to calculate the phase change, and that's based on an equation, and we're not going to go in detail for this video, but the next one we will. So calculate the phase change. So that's the angle file. Next part, once we have the phase, we can calculate the temperature by using an equation. It basically relates the temperature relationship to the phase adjusted by a constant. So that's the basics behind that. Okay, and then once we do that, the next step is to read the optical sensor data from the text file. And again, the important input is like these right here: the channel number, the time, year, the month. These are strings we defined earlier. And this function basically calculates the delta temperature change, the delta T. And the next, I guess, okay, let's go on and go on to the high level for all the cells, and then we'll go on more detail. for these later on. So this part is where, let's see, let me go ahead and run this through once. So to execute these cells, just hit this button right here, evaluate cell in events. Notice if there's an error, it's going to show up on the command line, command window. Okay, so right here I just have a surface plot of this is basically an example to see what's going on. You can select the slice number here. Oh, the delta T is already pre-selected. The slice already pre-selected. Remember that we select the slice and it outputs a delta T. But the slice here is where you can actually change the magnitude. Here, I'll just plot it out. So if you change the slice number, that will change the magnitude image, which magnitude image you're going to see. So this is the magnitude image for the third slice, fourth one. Let me just comment that out. See that? Now this is the fourth slice. This is still the third one because I program it to where the temperature, anything has to do with temperature, it's not going to change every time you change the slice number here at this point. So this is every time you change the slice number here, it's going to change the magnitude image. And this is just to see what's going on, like if you want to determine where the optical sensor is, and you can kind of like want to look over different slices and track the whole. And you can use this to track it. Right, and X and Y basically defines the starting point, the center point of your image, and then later on, these coordinates were used to create a zoom in window, if you will. And it's gonna be like plus 80 on top, plus minus 80 on bottom, pixels that is, minus 80 pixel on the left, minus 80 pixel on the right. So it'd be like a zoom in image, and that's for this part. It's not very crucial. And then this is where you select the range for the color axis, the color bar. So you want like 15 here. There'll be 15 here, right there. Figure 2 is the plot we were looking at earlier, which is the magnitude only. Figure 3 is the plot of the mask that we talked about earlier with threshold. So the background is masked, it's air. So you set all to 0, and in here is all 1. So everything multiplied by 1 is the number itself. So this is the mask we're going to use. So I was experimenting with a new way to estimate temperature, and it's called referenceless method. And I'll explain with that. So that's why you have this cell block called reference site. So basically, I have to pick a reference point in the spatial domain instead of like the initial image as a reference. But don't worry about that for now. That's like a different project. Just worry about, so in this video was worry about the traditional way to measure temperature. So that's where the original reference method cell comes into play. So here we have a way to plot temperature for different points. Like here's one point, you plot over time. Here's another point, plot over time. So that's where you see 1 millimeter, 3 millimeters, 5 millimeters, 10 millimeters. So that's like the distance from a starting point, and you measure different points onwards. and you have that over time. And of course, we can go in more detail for these functions later on, but this is a high level description of the functions. Again, just ignore this for now. Uh, this is just a different way. And then the last cell, basically, if you want to export certain files into Excel, then you want to look at this as an example. And then every time you want to export, make sure there might be some issue with the data being rows or columns. So I had to deal with that where I just I had to take the transpose of the data. So when you export it, it makes more sense, like the times, it's on the left, and just like rows and columns issues. So this is where you export the file to Excel. Okay, so I guess this will conclude this high-level tutorial for now. In the next video, we'll go into more detail in depth of each function and what it does. Alright, guess I'll see you in the next video.